Beneath the hazy orange smog of Saturn's moon, Titan lies one of the greatest mysteries in the entire solar system. A world that feels eerily familiar yet utterly alien. For decades, its surface was completely hidden, until NASA finally found a way to slice through the haze and reveal what Titan really is. And what they found was astonishing. Our first close brush with Titan came in 1979, when NASA's robotic explorer, Pioneer 11, became humanity's first visitor to Saturn. Its mission: scout the rings, scan the moons, and bring back clues from a realm we had only ever imagined. Titan wasn't a new discovery. We've known about it since 1655, when Dutch astronomer Christian Huygens first spotted it. And it's not exactly subtle. Titan is enormous, bigger than Mercury, and 50% wider than Earth's moon. But distance kept its secrets locked away. So when Pioneer 11 finally arrived, scientists were desperate for their first real look. Instead, they saw nothing but a swirling cocoon of deep orange clouds, thick, opaque, utterly impenetrable. Still, Pioneer could sniff what it couldn't see. And what it detected sent a jolt through NASA's science teams. A dense atmosphere rich in nitrogen. That's the same dominant ingredient in Earth's air. Then came the real shock. Hydrocarbons on Earth. Hydrocarbons are everywhere. Propane, gasoline, natural gas. They're simple carbon and hydrogen structures. But more importantly, they're the chemical scaffolding used by life itself. Titan's atmosphere was loaded with methane and other organic molecules. Not life, but the ingredients of life. And suddenly, this hazy moon went from being just another satellite to one of the most tantalizing worlds in the solar system. Important molecules like DNA, proteins, and the chemistry of life itself are all built on hydrocarbon foundations. Here's a word that'll sound familiar: carbohydrates. Same idea, carbon and hydrogen, but now with oxygen mixed in. And that's the crucial part. Find oxygen on Titan, and you don't just have the ingredients for life. You have the fuel that life runs on. And yes, Titan does have oxygen. But it's buried deep, and we're not there yet. Hold that thought. As Pioneer 11 swept past Titan, it also measured the moon's gravity. And this is where things get weird. For a world larger than Mercury, Titan's gravity is surprisingly weak. That tells us Titan isn't dense, meaning it can't be made entirely of rock. And that opens the door to some wild possibilities. Thick atmosphere plus low gravity equals a human with a wingsuit could literally jump off a cliff and fly for as long as they wanted. Titan is one of the few places in the solar system where humans could actually fly under their own power. And for NASA engineers, that combo makes one kind of vehicle irresistible. A flying probe. NASA now had a tantalizing puzzle. A distant world with Earth-like chemistry, hidden oceans of potential, and a smothering orange sky keeping everything secret. All they needed was the technology to actually see through the haze. It would take 25 years. In 2004, the Cassini spacecraft, a joint mission between NASA, the European Space Agency, and the Italian Space Agency, finally arrived. Armed with radar and infrared eyes, Cassini could pierce Titan's atmosphere in ways Pioneer never could. Over a 13-year mission, Cassini swept past Titan 127 times, gradually peeling back the layers. And what it revealed was staggering. Titan is the only moon in the solar system with a real atmosphere, and not just any atmosphere, but one 4 times denser than Earth's. That thickness traps almost no heat. Instead, it blocks what little sunlight reaches Saturn's orbit, creating a bizarre reverse greenhouse effect. As you descend toward the surface, methane in the air, it's colder and colder, until it condenses and falls as rain. Methane rain on methane lakes. On a crust of ice hardened to the strength of granite, Titan's average temperature is minus 179 degrees Celsius, just a few degrees above the freezing point of methane at minus 182 degrees Celsius. It is a world with its own complete hydrological cycle evaporation. Clouds, rain, rivers, lakes, except it's all made of liquid rocket fuel instead of water. A frozen Earth echo, running on an alien chemistry we're only beginning to understand. The result? Flowing rivers, lakes, and seas across Titan's frozen surface, making it the only world besides Earth with stable liquid on the ground. The engineers behind Cassini weren't taking any chances. They knew Titan was hiding something extraordinary. So, the European Space Agency included a secondary probe, Huygens, named for the Dutch astronomer who first spotted the moon in 1655. Huygens was built to parachute through Titan's thick atmosphere and capture images. All the way down. In January 2005, Huygens began its historic descent. Based on Cassini's radar maps, the target landing site was believed to be the shoreline of a small lake. The probe was designed to survive a variety of terrains, from rugged mountains to smooth plains, even liquid oceans. Its batteries were enough for 3 hours of operation, with the first 2.5 spent drifting slowly through Titan's alien sky. As Huygens finally pierced the clouds, a strange landscape revealed itself. A dark valley stretched between brighter mountain ridges. Carved into the slopes, a network of drainage channels and streams snaked across the terrain some hundreds of meters wide, several kilometers long. These channels had been shaped by methane rains, cutting their way into the mountains over eons. The probe descended into the heart of that dark valley. But there was no liquid waiting. Instead, Huygens was about to land on a dried-up riverbed, a silent testament to Titan's shifting methane cycle. When it touched down, the surface gave slightly, leaving a 12-centimeter dent. Huygens bounced, slid 30 to 40 centimeters across the icy soil, wobbled a few times, and finally came to rest. Titan had been explored for the first time in human history. And though the rivers were dry in that exact spot, the evidence was clear. This was a world alive with its own weather, its own cycles, its own liquid flowing beneath alien skies. As the camera sweeps across Titan's surface, the most striking revelation isn't just how alien it looks, it's how surprisingly familiar it feels. Strip away the orange haze, and it could be the bottom of any river on Earth. Large, rounded stones smoothed by flowing liquid rest among smaller pebbles on what looks like sandy ground. Only these aren't rocks. They are chunks of water ice, frozen solid. The mountains, too, are made of ice. Water means oxygen, H-O, but frozen. It can't support life. At least not yet. The muddy terrain surrounding the lander is something else entirely. Scientists call it a hydrocarbon mixture, strange and soft like snow, with a thin, crispy crust on top and a yielding texture beneath. As the camera pans, waves shimmer in the air heat from the probe's lamp, causing evaporation. At one point, a single droplet of methane dew slides past the lens. Looking upward, the sun hangs tiny in the sky, only 1/10 the size it appears from Earth. Even at midday, Titan's light is muted. Like Earth's twilight hour, Huygens' landing revealed a lot, but not the liquid methane that scientists had hoped to find. It had landed in the right place, the riverbed, but at the wrong time. Where had the liquid gone? The key lies in Titan's methane cycle, analogous to Earth's water cycle. On Earth, water evaporates, condenses into clouds, and falls as rain frequently, because the sun's energy drives rapid evaporation. On Titan, sunlight is scarce, so methane evaporates very slowly. When it does, the vapor is trapped in Titan's dense, high clouds, capable of storing enormous amounts before any rain falls. The result? Long droughts lasting hundreds of years, followed by sudden, torrential downpours capable of flash flooding entire regions. Huygens did not land in Titan's rainy season, but that didn't mean it was completely dry. Over its 13-year mission, Cassini continued observing Titan, revealing that during dry seasons, liquid methane is mostly limited to the North Polar regions. Here, bright reflections of sunlight off smooth surfaces marked the first confirmed body of liquid methane on Titan, Ontario Lacus, named for Earth's Lake Ontario. Titan's lake mirrors its terrestrial counterpart in shape, though it's about 20% smaller, covering roughly 15,000 square kilometers. Despite its size, it is shallow, averaging 40 centimeters to 3 meters deep, and unnervingly still, with waves barely 3 millimeters high. Titan had rivers, lakes, rain, and yet it was a world wholly alien, familiar and strange at once, a planet both frozen and alive, hiding secrets that would keep humanity fascinated for decades to conduct to the naked eye. Titan's lakes appear glass-smooth, though lower gravity and higher air pressure should make waves larger. Its North Polar Ocean, Kraken Mare, spans 400,000 square kilometers smaller than Earth's Black Sea, and even tides rise up to 1 meter. Titan also hosts ice volcanoes, erupting slushy water mixed with ammonia, which acts as antifreeze. Beneath the frozen crust lies a partially frozen slush layer, and below that, a subsurface ocean atop a rocky core. Here, water meets hydrocarbon-rich material, creating the basic fuel for life. NASA's Dragonfly mission, a nuclear-powered helicopter, will launch in 2028 to explore Titan's surface and search for signs of life. Arriving in 2034,